All right, hey guys, how's it going? So we're going to go ahead and look at the review for the POLYOP 2 test. So we start with number one. Number one and number two are just factoring out the GCF. So what is the GCF of the following polynomial? The way that we would do this is we would basically go through, look at all our numbers, and ask ourselves, what's the biggest number I can divide all of these numbers by? Of course, you want to use your calculator for something like this. And with something like this, I would highly encourage you guys to list out your factors this way. So you would do 12 divided by x for your factors for x. And so you go second graph, you list out your factors. So 1 and 12, 2 and 6, 3 and 4. Once your numbers start to repeat, then you know that you're done. And of course, if you want to list your numbers out here, you can. 1 and 12, 2 and 6, 3 and 4. And then, then you go in and you do the factors for 64. What I always like to do first is I like to find the factors for the smallest number. And then all I have to do is just try each of these. So I know for sure I can factor all of them by 1. The next biggest is 2. I can divide both of these by 2 since they're all even numbers, so I can also do 2. With 3, we would have to go in and check. So the way that you check is you just check the next number. Negative 64 divided by 3. We get a decimal, so we know we can't do it. Next biggest is 4, so I would do negative 64 divided by 4, which gives me negative 16, which is means that I can factor that, and then so now I try the biggest number, negative 256 divided by 4, and since, again, since it's a whole number, that means that I can factor it. So I can also factor this by 4. So now that I can factor by 4, 4 is my GCF because it's the biggest. Of course, I can try 6, negative 64 divided by 6. Again, gives me a decimal, so that doesn't work. And then negative 64 divided by 12. And again, decimal, so that doesn't work. So the biggest number that I can divide all these by is going to be 4. So my GCF here is 4. Of course, you also have to know how to factor this out if you were rewriting this. So if I divided this by 4, so I would do 12 divided by 4, which would give me 3x squared. Negative 64 divided by 4. Again, I've already done that on my calculator. And that gave me negative 16. So I have 3x squared minus 16. The 64 had an x attached to it, so I have 16x. And the negative 256 divided by 4 gave me negative 64. So if I was doing the whole thing, that would be my answer. All right. For number 2, what is the GCF of the following polynomial? Again, you always factor out the smallest. Factors of 4 are 1 and 4 and 2 and 2. So what's the biggest number I can divide all these by? Of course, I can do 1. Next one I would try is 2. Again, these are all even numbers, so I can do 2. And then I would try 4. 54 divided by 4. Oops. Which gives me 13.5, so it doesn't work, so it can't be 4, so it has to be 2. Again, I'm going to go ahead and write this correctly, so I divide all these by 2. We get 2x squared plus 24, 25, 26, 27x plus 81. All right, and then so that would be my factor. And if they were simply asking me for my GCF would be 2. If they're asking me to rewrite this, then that would be the correct written expression. Remember that you can also multiply this out, so distribute the 2, and you should get right back to the original. All right, we jump down to the bottom, which says which of the following is the complete factorization of the product, and they give us the product there. One thing that I do notice is on all of my answer choices, they have a 3 out in the front, which means that what I can do is I can factor out a 3. So I can start off by dividing all these by 3. If I divide these all by 3, 15 divided by 3 gives me 5n squared. 27 divided by 3 gives me negative 9n. And then negative 6 divided by 3 gives me negative 2. All right, so once I've factored this out, now I can factor this using my Xbox. All right, so first and last, so we have 5n squared. Last is going to be negative 2. We multiply then we label ABC. A times C goes up top. So we have 5 times negative 2, which gives me negative 10. And then negative 9, my b goes on the bottom. That's how I always remember it. B for bottom. B goes on the bottom, which is negative 9. So factors of negative 10 that give me negative 9. On your calculator, you would do y equals. You would list your factors for your top number, which is the negative 10. So we do negative 10 divided by x. And then to have your factors added together, you would do negative 10 divided by x plus x. Again, it should be the exact same number both times. So then we go second graph. Now, the second equation makes it really easy because all we do is just look for our bottom number on this side, on the y2 column. So I'm looking for negative 9 on the y2. Technically, what my second equation does is it just adds my terms together. So 1, negative 1 plus 10 gives me 9. 1 minus 10 gets me negative 9. 2 minus 5 gets me negative 3, right, so forth and so on. So I see the negative 9 there, which means that my two factors are 1 and negative 10. All right, so whenever I plug these in, remember that technically what we did is we split that negative 9 into two terms. So whenever I plug these in, I should have 1x and negative 10x. Now, of course, it doesn't matter where I plug them in. I could have put the 10 up here and the 1 over here, and it wouldn't have made a difference. Or I guess in this case it's n, since we're dealing with n's. All right, so a lot of times people have trouble factoring something like this out. Remember that n squared has to be n and n, so we at least know that. And now the question is, where does the 5 go? Let's get this over a little bit. All right, so does the 5 go here or does the 5 go there? And the answer is we can't just assign it to a random spot. We have to make sure that it lines up. So with problems like this, we want to look across this way first. So looking at these two, looking across this way, looking at the 5 and the 1, I want to ask myself, is the GCF 5? Well, the GCF of 5 and 1, the biggest number I can divide both of those by is going to be 1. So this technically needs to be 1n or 1x. But whenever I go up and down and I have 5n squared and negative 10n, then the 5 and the negative 10, I can divide both of those by 5, so the 5 should go up here. And now whenever I multiply 5n times 1n and I multiply them in, I should get what I have in here, which is 5n squared. You have to make sure that you get this from these two before you move on. All right, so we have the 5n squared by multiplying 5n times 1n, which gives me 5n squared. So now that we have that, now we can move on. So we have 1n times something gives me 1n. Well, that something has to be 1 because I already have the 1n. Then 5n times something gives me negative 10. That has to be negative 2. And then always make sure that you check this one, again, by multiplying that and that together. So 1 times negative 2 gets me negative 2. So that means that my factors here are going to be the 3. Then on top I have 5n plus 1. And then on the side I have n minus 2, which corresponds with B. 3 on the outside, 5n plus 1, and then n minus 2. All right, for number 4, it looks a little bit different. But again, if I look at my answer choices, it looks like nothing can be factored out. And it looks like they can still factor this out the same, so let's go ahead and factor this out just like we would any other problem. So let's go ahead and do our X box. All right, so we start with the first and last. So we have 6x squared. Even though we have y squared, we just ignore that for now. We just do this like we would any other problem. So we have minus 49y squared. Again, up top we have a times c. On the bottom we have b. So my b is my negative 7. Remember that you don't need any variables with this. It's just negative 7. Up top we have 6 times negative 49. Which is going to give me negative 294. All right, and then I go into my calculator and I calculate my two sides. So we have negative 294 divided by x, and negative 294 divided by x plus x. All right, then we do second graph. Again, we're looking for our bottom number. In this case, our bottom number is negative 7, so I'm looking for negative 7 on this column, which I'm going into the negatives. There's negative 7, so I have positive 14 and negative 21. And then we just have to remember that we technically, once again, split the middle term, so I don't just have x, I also have x and y, so I should have xy in the terms that I just plugged in. All right, and now we factor this out just like we would any other problem. X squared, again, factoring out that first box, x squared is still x times x. And then the 6. Sometimes you can take the entire number out, like we did in the previous problem. We took the entire 5 out, and we just put it either on top or on the side, depending on how you lined yours up. For this one, though, we're going to have to figure out, can we take the whole 6 out? So if I look across this way, the GCF, in other words, the biggest number I can divide 6 and 14 by is only going to be 2. I can only divide these by 2, 2 being the highest number I can divide out of both. Now if I look up and down this way, 6 and negative 21, I can divide both of those by 3, 3 being the highest number, the highest GCF. So we have a 3 there. So this time I didn't really pull out the 6 necessarily all in one piece. I pulled it out in 2 pieces. I pulled out a 2 and I pulled out a 3. But luckily for me, whenever I multiply these two back in, 3x times 2x, I still get 6x squared. So as long as I get the inside, it's okay. So we had to take out the 6 in 2 parts, as a 2 and as a 3. All right, so now we multiply 2x times something gives me 14xy. 2 times 7 gets me 14. X I already have. I still need the y, so this needs to be 7y. And then we have 3 times something gives me negative 21. That has to be negative 7. And then again, the x is coming in the box. Nothing else is coming in from here, no other letters, so this one has to have the y that I'm missing. So that should be minus 7y. And then when we multiply these last two, again, I always say make sure that you check this last box. 7y times negative 7y should give me negative 49y squared. And so my factors here are 3x plus 7 and 2x minus 7y. Oops, I forgot my y here. So then I just match it. 3x plus 7y, which is there. 2x minus 7y, which is there. So there's my answer. A. All right, in the next video, we'll look at 5